Here I want to show what it means to write decimals in terms of fractions or fractions in terms of decimals. So essentially what we're looking at is writing different numbers but going back and forth from decimal into fraction form or from fraction into decimals. So the first thing that we have to do is we have to look at going from decimals into fractions. To do that, you have to look at the placement of the last digit, and that is going to end up being what your denominator is. Now the actual decimal itself then is going to become the numerator. Okay, and then once you do that, you would reduce your fraction. So here, notice I have 0.18. The 8 right here, so this 8 is in the hundredth spot. Because it's in the hundredth spot, what that actually means is that my denominator is going to be 100. Now the actual decimal itself becomes the numerator, so this is going to be 18 over 100. Once you get that finished, you have to reduce. So if I look at 18 and 100, they're both even, so a good place to start would be to divide by 2. So 18 becomes a 9, 100 becomes 50. If you look at 9 and 50, you have nothing else in common. Therefore, you have finished your problem, and this is your result. Okay. So let's look at another one. I have 1.575. So the first thing that I need to look at is I need to look at this very last digit. And this last digit is in the thousandths spot, which says the denominator is going to be 1,000. Now the decimal itself is what has to be the numerator. So it's going to be 1575, and that's what goes in as your numerator. Just because this 1 over here is actually a whole number does not mean it gets left off. What it does mean is that in this problem we are creating an improper fraction. Now you will only change that to a mixed number if you are asked for a mixed number. Otherwise, you are expected to leave it as a mixed fraction. So here I have 1575 over 1,000, so you have to reduce that down. The first thing that you could notice is that both the top and bottom end in a 5 or a 0, which means you can divide a 5 out. And so when you do that, takes the top down to 315. And then when we look at the bottom, we have 1,000 divided by 5, which is going to give you 200. Again, I have a 5 and a 0 in both top and bottom, which means I can take another 5 out. When I do that, 315 is going to become a 63. 200 is going to become 40. When you look at these two digits, there is nothing else that's in common with them. Therefore, this is your result. Okay. Now notice it is an improper fraction because nowhere in my directions does it say convert to a mixed number. It just says change to a fraction in lowest terms. Now last we have 4,567.2. Again, we're going to look at this decimal here, and this is in the tenths spot. That being said, because it's in the tenth spot, it means the denominator is a 10. And then on the top I have my digits, so 4,567.2. And then again, just like always, you have to reduce. So here I can divide a 2 out of both top and bottom. So this is going to become 22,836 all over 5. And then the only thing that's left to do would be to determine if you can divide a 5 out, which in this case you can't. Therefore, this is my end result. So that is taking decimals into fraction form. That being said, we can go from fractions into decimal form by essentially reversing the process. In order to do that, however, we need to go back old school. And by that, we have to do division. So the easiest way to do this would be to use old school long division. That is, if you are told you're not allowed to use a calculator. Okay? So, most places demand that you show your work. And so here, when we have 3 over 16, what we're really talking about is 3 divided by 16. And so what you have to remember about old school long division is that it's set up where we have the curvature. And when we're talking about putting things in, your numerator goes underneath, your denominator goes on the outside. Okay? And then of course up on the top here would be your result or solution, depending on how you want to phrase it. So that is your setup for your long division. So here I want to show you what it would look like using the fact that this is a proper fraction. So the way it looks is we would set up our division here, and we would have 3 on the inside, and we would have 16 on the outside. And so that's essentially what we are doing. Okay? So obviously 16 does not go into 3, but what we do know is that 3 would be the same as looking at it as 3 points, say, throw in a couple of zeros. So 3 does not go into, or 16 does not go into 3. Remember, wherever the decimal point is inside your division, you just simply place it in that same place above for your solution. And so here, I can now look at, does 16 go into 30? Well, the answer there is yes, it goes into it once. 16 times 1 is 16. We would subtract away. And so here we would be left with 30 minus 16, which gives you 14. 16 does not go into 14, so we can drop down our 0. And look at, does 16 go into 140? Well, it does. It will go 8 times. 16 times 8 is 128. We would subtract that away. And that is going to give you 12. Sixteen doesn't go into 12, so again you would carry the 0 all the way down. So this becomes 120. So 16 can go into 120 7 times. 16 times 7 is 112. We would subtract, and this should give you 8 left. And again, we could go further if you wanted, so add another 0, carry it down. This would be 0. 16 can go into 8 5 times. 16 times 5 is 80. You would subtract your 80 away, gives you 0. Because you got a 0 here on the bottom, it means there's nothing else to do. So it actually means that your decimal is this value right here on top as 0.1875. So this is being able to show your work. To verify your solution, I would take your 4-function calculator and actually do 3 divided by 16, and notice it is 0.1875. So being aware of how to use your calculator but also do the long division piece is really important. Okay. So here I have 4 divided by 15. So I've got 4 divided by 15 is what that fraction says. And so again, to show your work, I would consider doing the long division, which says the 4 goes inside, 15 goes outside, and I would go ahead and put in a couple of zeros and actually do the long division work. Okay? In order to speed things up a little bit here, 4 divided by 15 comes out, and notice I have a repeating decimal. Okay? So what we end up getting is 0.26666666666. Write them until you get tired, and then you round up the last one. Okay? So what this is called a repeating pattern. So it's a repeating pattern to the digits. The repeating part comes specifically from these 6s. Okay? So here what we would do is we would go ahead and we would show the pattern. So we would be able to state this as 0.2667. You draw a line on top which signifies that it is a repeating pattern and which part of the fraction is repeating. Okay. Now the next one I wanted to look at was 7 divided by 11. So again, you could do the same thing. I would set up your long division. Remember, the numerator goes on the inside, your denominator is on the outside. Okay? So again, if we were to look at that, 7 divided by 11, notice it gives you 63, 636363, blah blah blah, until you get down to where it rounded the last digit here. So we would end up with 0.6363, and you could draw it like that, repeating, or you could just simply say you have 0.63 and make that repeating. Either one gives you the result that you're looking for. And this one is a pure repeating fraction or decimal because all the digits are repeating. Okay? Not just some of them, all of them. Now the last one I wanted to look at is one where I'm starting with an improper fraction. So again, what you have as your numerator would go inside, your denominator goes outside. So if we were to do this, notice 13 goes into 16 and it goes in there once. Because I have this decimal here, I would put it up in the same place on top. So notice this is going to be a whole number with a decimal after it. You would subtract your 13 away, leaves you with 3. You would drop down a 0. 13 can go into 30 twice. 13 times 2 is 26. You would subtract it away. Leaves you with 4. Again, drop down your next 0. 13 can go into 4 3 times. So that's going to give you 39. Gives you 1 remaining. You can drop down your 0. 13 in this case obviously does not go into 10. And so you would put a 0 here. You could theoretically keep going and drop down another 0, and notice this becomes 100. And so we would look at how many times does 13 go into 100. Well, in this case it would go 7 times. So 13 times 7 is going to give you 91. When you subtract that away, get a 9, and notice this could keep going forever. Okay? So once you get there, you need to look at where you're supposed to round, and we have that you're rounding to the nearest thousandth. So you need to remember where your thousandth is. Okay, so this is tenths, hundredths, thousandths. So when I'm talking about rounding to my thousandth spot, I'm looking at this spot here. So to round it says I need to look at the spot next to it. Because the 7 is greater than 5, it means we would round up. So the actual decimal that we're looking at here as our answer would be 1.231. Okay, because we had to round. So you need to make sure that you are paying attention to whatever rounding decimals you have been given. Okay? So that is essentially everything that you need to know about going from decimals into fractions or from fractions into decimals. Remember, be sure to show your work and everything that you do. Do not just rely on your calculator, because remember, calculators have tendencies to break down. So do make sure you know how to attack it old school as well. If you have any questions, please let me know. Otherwise, remember to keep smiling, relax, and have tons of fun with your math. And as always, I'll see you next time.